Jake Miller tapped his pencil against his notebook as he stared at the physics homework in front of him. The afternoon sun filtered through the classroom windows of Riverdale High School, casting long shadows across the worn desks. Most of his classmates had already left, but Jake remained, determined to finish the assignment before heading home to help on the farm. "Still working, Jake?" Mrs. Patton asked, glancing up from her desk. "Yes, Mom. Just trying to figure out the best way to solve this momentum problem," Jake replied. Mrs. Patton nodded and returned to grading papers. What Jake didn't know was that beneath her appearance of an ordinary physics teacher with graying hair and reading glasses perched on her nose, Mrs. Patton was actually Zor Elia, a Proximan researcher studying Earth's educational methods for the Galactic Academic Council. Jake read the problem again. Calculate the force needed to stop a moving object of certain mass and velocity in a given distance. The textbook method involved several formulas, but as the son of farmers, Jake had practical experience with physics in action every day. He thought about the time he and his dad had to stop a rolling tractor on a downhill slope when the brakes failed. They had used hay bales to gradually slow it down. The memory sparked an idea. Jake began drawing a diagram, not using the standard approach from the textbook, but applying what he had learned from real life. He calculated the force by thinking about how many hay bales it would take to stop objects of different weights rolling down the hill behind their barn. He worked out a simple equation based on his observations that accounted for the compression of the hay and the transfer of energy. 2 hours later, Jake placed his completed homework on Mrs. Patton's desk. "All done?" she asked. "Yes, ma'am. I hope it's okay that I solved it differently than the book shows. It made more sense to me this way." Mrs. Patton skimmed his work, her eyes widening slightly. "This is interesting, Jake. I've never seen someone approach the problem quite like this." Jake shifted nervously. "Is it wrong?" No, Mrs. Patton said quickly. "In fact, it's quite remarkable. You've essentially created a practical application model that accounts for variables the textbook method doesn't consider." After Jake left, Mrs. Patton locked the classroom door and pulled out a small device that looked like a compact mirror. She scanned Jake's homework and transmitted the data to a receiver 50 light-years away. That night, as Jake helped his father fix the irrigation system on their cornfield, the images of his homework appeared on a massive holographic display in the grand chamber of the Galactic Academic Council. "This cannot be correct," hissed Professor Vex, a tall, thin alien with pale blue skin. "The human child has solved the momentum problem without using the standard unified equations." Dr. Kell, the head of Comparative Education Studies, adjusted her translator. "And yet, his answer is not only correct but accounts for real-world variables our models often simplify away." The council members murmured among themselves, their various appendages gesturing at different parts of Jake's work. "What's most remarkable," continued Dr. Kell, "is that this approach comes naturally to him. He didn't learn it. He intuited it from his experiences on a high-gravity world." "But that defies everything we know about educational development," protested Professor Vex. "Theoretical understanding must precede practical application." "Perhaps," said Dr. Call thoughtfully, "but only according to our understanding. We must consider that these Deathworlders, these humans, might develop cognitive pathways different from any species we've studied before." As the debate raged on among the brightest scientific minds in the galaxy, Jake Miller finished his chores, ate dinner with his family, and went to bed, completely unaware that his simple homework assignment had just challenged the fundamental assumptions of galactic educational theory. And Mrs. Patton, watching the stars through her bedroom window, smiled. The experiment was proving far more interesting than anyone had anticipated. The massive space station Celestia Prime hung like a jewel against the backdrop of swirling purple nebulae. Inside the grand chamber of the Galactic Academic Council, 12 of the galaxy's most brilliant minds gathered around a floating hologram of Jake's homework. "I have studied it for 3 full cycles," said Professor Nix, a six-limbed arachnian whose compound eyes reflected the light of the display. The human solution lacks mathematical elegance, yet it works perfectly. Dr. Zixlara, a fox-like Vulparian scientist with russet fur and bright yellow eyes, moved closer to the display. Unlike her colleagues, who viewed the homework with confusion or dismissal, she saw something fascinating. "Look here," she said, pointing a slender finger at Jake's sketches of hay bales. "The human isn't just solving for momentum. He's intuitively accounting for energy absorption through deformation of materials." Professor Gulnar, a gelatinous being who floated in a gravity suspension field, rippled with disagreement. "But he doesn't use the Tholian equations. How can his calculations be trusted?" "Perhaps," Dr. Zixlara suggested, "our equations aren't the only way to understand the universe." The chamber erupted in gasps and murmurs. To suggest that the mathematical frameworks developed over 20,000 years of galactic science might be incomplete was almost heresy. High Counselor Dram, an ancient Medusan with translucent skin that revealed his 3 pulsing brains, raised a hand for silence. "Dr. Zixlara, explain your theory." Zixlara moved to the center of the chamber. "Consider the planet these humans evolved on. Earth is what we classify as a Class 9 death world. High gravity, extreme weather, dangerous predators, and wildly fluctuating temperatures." She waved her hand, and the hologram changed to show Earth's diverse environments. Most spacefaring species evolved on stable, mild worlds. Our mathematical understanding developed in controlled environments, but humans had to survive by understanding their world physically before they developed abstract mathematics. Professor Nix clicked his mandibles skeptically. "Are you suggesting that living on a death world gave humans some special insight?" "I'm suggesting," Zixlara said carefully, "that their survival depended on developing intuitive understandings of physics that we, with our safer evolutionary paths, never needed." High Counselor Dram floated closer to the hologram. "Then this child's homework is a window into a completely different way of understanding universal principles," Zixlara finished. "One based first in physical reality and later formalized into mathematics. The reverse of our approach." The council members exchanged troubled looks. For millennia, they had assumed that their mathematical models were the only valid way to understand the cosmos. The idea that a species from a backwater death world might have developed alternative, but equally valid approaches was disturbing. "This requires further investigation," Dram announced. "I propose we commission a specialist team to study human problem-solving approaches." "I volunteer to lead this research," Zixlara said quickly. Gulnar's gelatinous form rippled with skepticism. "What if this is simply one unusual human? Perhaps this Jake Miller is an anomaly." "Then we need more samples," Zixlara replied. "More homework from more humans. We need to determine if this intuitive approach is widespread in their species." After hours of debate, the council voted 7-5 in favor of expanding the research. "Very well," Dram concluded. "Dr. Zixlara will lead a small team to analyze more examples of human problem-solving. Our agent on Earth will be instructed to collect additional samples." As the meeting ended, Zixlara lingered, studying Jake's simple sketches. There was something beautiful in their rough practicality, something that challenged everything she had been taught. Meanwhile, on Earth, Jake Miller received his homework back with a simple A+ written at the top. He smiled, tucked it into his backpack, and thought no more about it as he headed to his next class, completely unaware that his work was about to change how an entire galaxy understood physics. Susan Reeves frowned at her computer screen in the quiet corner of NASA's research lab. As an astrophysicist specializing in deep space communications, she had noticed something odd over the past few weeks. Strange signal patterns, too regular to be natural, but too complex to be easily decoded. "Got you," she whispered as her tracking program finally pinpointed the source. The signals were being transmitted from a small town in Iowa, of all places. Even stranger, they seemed to be directed at a specific point in the Proxima Centauri system. Susan tucked her brown hair behind her ear and made a decision. She had vacation days saved up, and her curiosity wouldn't let this go. 3 days later, she parked her rental car outside Riverdale High School. "I'm here to observe some science classes," she explained to the principal, showing her NASA credentials. "We're studying various teaching methods across the country." The principal looked impressed and immediately offered her a tour. By afternoon, Susan was sitting at the back of Mrs. Patton's physics class, watching the teacher closely. There was nothing obviously suspicious about the older woman. Her teaching methods were good, if a bit unusual. She encouraged students to find their own ways to solve problems rather than following textbook methods strictly. Susan noticed one boy in particular, a tall, lanky teenager named Jake Miller, who seemed to have a special knack for finding creative solutions. After class ended, Susan lingered, pretending to make notes. When the last student left, she closed the classroom door. "Who are you really?" Susan asked directly. Mrs. Patton looked up, startled. "I'm not sure what you mean." "The signals you're sending to Proxima Centauri," Susan said calmly. "They're quite sophisticated, but not impossible to detect if you know what to look for." Mrs. Patton's face changed subtly. She stood straighter, her movements becoming more precise. "You're very observant, Dr. Reeves. Most humans wouldn't have noticed." "Most humans don't work in deep space communications," Susan replied. "Are you going to tell me what this is about, or do I need to involve other agencies?" Mrs. Patton, or whatever her real name was, seemed to consider her options. Finally, she sighed and pressed a small button on her wristwatch. The air around them shimmered slightly. "We can speak freely now. No one will overhear us," she said. "My real name is Zor Elia. I'm a researcher for the Galactic Academic Council, studying Earth's educational methods." Susan blinked, trying to process this information. "You're not human." "I am Proximan," Zor Elia said. "We look very similar to humans with minor differences. My species has been observing Earth for centuries." "And the signals?" Susan asked. "I've been sending some interesting student work to my colleagues," Zor Elia explained, "particularly Jake Miller's. His approach to physics problems has caused quite a stir." She showed Susan the transmission device and explained how Jake's homework had challenged fundamental galactic scientific principles. "So Jake's homework is being studied by aliens," Susan said slowly, "because he solves problems differently than your scientists do." "Exactly. Human intuitive reasoning is unique among known species. You evolved on what we call a death world. Your survival required practical understanding that other species developed theoretically." Susan paced the classroom, thinking, "Does Jake know about this?" "No one knows. We're merely observers." "But you could be more," Susan said, an idea forming. "If human problem-solving is so valuable, why just study us secretly? Why not engage openly?" Zor Elia looked surprised. "That would violate protocols. Earth isn't ready for galactic integration." "Maybe not full integration," Susan said. "But what about an exchange program? Bring some of your students here. Let them learn alongside humans. We both benefit." "The council would never approve." "They might," Susan argued, "if they understood how much more they could learn through direct engagement rather than just studying homework assignments." Zor Elia was quiet for a long moment. It would be unprecedented. But after seeing Jake's work, she nodded slowly. "I will present your proposal to the council." Susan smiled. "And I know just the student who should be first in the program." Jake stared at the 5 new students standing at the front of the classroom. The principal had explained they were part of a special international exchange program, but something about them seemed off. "Please welcome our new classmates," Mrs. Patton said with a smile that Jake now noticed didn't quite reach her eyes. "Alan from Sweden, Lyra from Brazil, Krill from Canada, Nev from Japan, and Zora from Australia." The new students nodded stiffly. They were all dressed in perfectly normal clothes, but they moved awkwardly, as if they weren't used to their bodies. Jake watched as they took their seats, noticing how carefully they placed their backpacks and arranged their notebooks. During lunch, Jake sat at his usual table with his friends Bill and Amy. The new students clustered together at a corner table, examining their food with puzzled expressions. "That krill guy keeps staring at you," Amy whispered to Jake. Jake glanced over and caught the eye of the shorter boy with light brown hair. After a moment of hesitation, Jake waved him over. "You want to join us?" Jake asked. Krill nodded and carefully carried his tray to their table. "Thank you for the invitation," he said in an oddly formal way. His accent was strange, not quite Canadian or anything else Jake could place. "No problem," Jake replied. "How's your first day going?" "It is challenging," Krill admitted. "Your learning methods are different from what I am accustomed to." Over the next week, Jake noticed more strange things. During physics class, Krill became visibly frustrated when Mrs. Patton asked them to design a simple pulley system. "The equation should come first," he muttered. "How can we build without calculating every force precisely?" Jake showed him how to set up a basic pulley. "Sometimes you just need to try it," he explained. "See what works, then adjust." Krill stared at Jake as if he had suggested something revolutionary. The science fair was announced 2 weeks later. Students would work in pairs on projects demonstrating fundamental scientific principles. Mrs. Patton paired Jake with Krill. "We could do something with gravity," Jake suggested as they brainstormed ideas. "Maybe build a model to show how different masses affect gravitational pull." Krill looked uncomfortable. In Canada, we would calculate the gravitational constants first, then create a mathematical model." "We can do both," Jake offered. "I'll build something physical, and you can do the math behind it." They worked in Jake's garage after school. Jake's dad had an old metal workshop where Jake started building a demonstration model using ball bearings of different sizes rolling around curved surfaces. Krill watched, fascinated, as Jake shaped the metal without detailed blueprints, using his hands and eyes to judge the curves. "How do you know it will work?" Krill asked. "I don't, not exactly," Jake admitted. "But I can feel when something's right. My grandpa taught me to work with metal. He always said your hands know things your brain hasn't figured out yet." The night before the science fair, they hit a problem. Their model wasn't showing the expected results. The smaller balls were moving too quickly around the curve. Krill was panicking, rechecking his equations over and over. "It should work. The math is perfect." Jake studied the model, running his hand along the metal curve. "It's not smooth enough here," he said, pointing to a section. "The surface tension is different. That's affecting the smaller balls more than the larger ones." Krill stared at him. "How can you possibly know that?" Jake shrugged. "I can feel it. Here, touch this part, and then this part. Feel the difference." Reluctantly, Krill ran his fingers over the metal. His eyes widened. "Yes, I feel it. But there's no equation for this in our basic models." "Not everything needs an equation," Jake said, already working to fix the problem. "Sometimes you just need to pay attention to what's happening in front of you." As they worked through the night, Krill watched Jake with growing amazement. For the first time, he was beginning to understand what the Galactic Council found so puzzling about humans. They didn't just think differently. They experienced the physical world in a way his people never had. The science fair was a success. Jake and Krill won first place with their gravity model. As they packed up their project, Dr. Susan Reeves approached them. "Impressive work," she said. "Would you both be interested in joining a special study group? We're researching different learning methods." Jake looked at Krill, who nodded eagerly. "Sure," Jake replied. "When do we start?" "Tomorrow after school," Susan said. "Mrs. Patton's classroom." The next day, Jake was surprised to find all 5 exchange students there, along with Mrs. Patton and Dr. Reeves. The classroom door was locked, and the windows were covered. "What's going on?" Jake asked. Mrs. Patton smiled. "Jake, it's time you learned the truth. This isn't just a study group. Over the next hour, Jake listened in shock as they explained everything. The alien observers, the Galactic Council, how his homework had started it all. He looked at Krill with new eyes. "So you're not from Canada," Jake said slowly. "You're from another planet." Krill nodded. "I am Centaurian. My real name is difficult for humans to pronounce." Jake took a deep breath. "This is a lot to take in. I understand if you're angry we deceived you," Susan said. Jake thought for a moment. "I'm not angry, just surprised. But it explains why Krill was so confused about my methods." Krill leaned forward. "That's what we want to understand. Your approach to problem solving is unlike anything in our education systems." Dr. Zixlara, who had been disguised as Zora from Australia, spoke up. "We believe it has to do with your species' evolution on a high-gravity planet with extreme conditions." She activated a small device that projected a hologram showing Earth compared to other inhabited planets. "Most spacefaring species evolved on much more gentle worlds," she explained. "Our bodies and minds developed in environments where survival was less challenging." "What does that have to do with homework?" Jake asked. Susan answered. "Think about how you solve problems, Jake. You use your hands, your physical experience. You feel the metal and know it's not right. That's because your ancestors needed those skills to survive Earth's harsh conditions. Whereas my people," Krill added, "evolved on a stable planet with few predators or weather extremes. We developed abstract thinking first, physical skills later." Jake nodded slowly. "So when I solve physics problems by thinking about farm equipment, you're using cognitive pathways that don't exist in our brains," Dr. Zixlara finished. "Your species developed a unique integration between physical experience and abstract thought." "But many members of the Council refuse to accept our findings," Krill said. "They believe proper science must follow established mathematical frameworks. They think human methods are primitive." Lyra, the tall Brazilian student, explained. "They don't understand that they're just different." Dr. Zixlara showed more holograms of the Council debates. "We need to prove that human intuitive methods are valid scientific approaches, not just lucky guesses." Jake watched the alien scientists arguing about his homework. It felt unreal. "What can I do to help?" he asked finally. Susan smiled. "We're preparing a demonstration for the Council. We want to show them that human problem-solving can address questions their methods have failed to answer." Dr. Zixlara nodded. "For centuries, our greatest minds have struggled with certain cosmic puzzles. We believe human insight might provide new approaches. But we need more than just Jake," Mrs. Patton said. "We need a team of human students, each with different strengths." Jake thought about his friends, kids he knew who had special ways of looking at problems. Bill, who could fix any engine just by listening to it. Amy, who saw patterns in numbers that others missed. "I think I know some people who can help," he said. As the meeting ended, Jake walked out with Krill. The world looked different now, knowing what he knew. "Is it weird being on Earth?" Jake asked. Krill smiled. "Less weird every day. I'm beginning to understand why your planet produced such unique minds." Over the next month, Jake helped gather a team of 5 students. There was Amy from Math Club, who could see patterns in numbers instantly. Bill from Auto Shop, who fixed machines by listening to them. Grace from Art Class, who understood spatial relationships better than anyone. Owen, who won every chemistry competition without memorizing the periodic table. And finally Zoe, who rarely spoke but could solve any puzzle put in front of her. They met every day after school in Mrs. Patton's classroom. Dr. Reeves and the aliens explained the challenge. "This is the Corellian gravity wave paradox," Dr. Zixlara said, showing them a hologram of swirling energy patterns. "It's a cosmic phenomenon discovered near the galactic core. For 800 years, our best scientists have tried to explain why gravity waves behave this way around certain star clusters. The hologram showed waves that twisted and bent in ways that defied normal physics. The math doesn't work," Krill added. Our equations say this pattern is impossible, yet we observe it throughout the galaxy. Jake studied the swirling patterns. It looks like water going down a drain, but with something blocking part of the flow. Amy nodded. The pattern repeats every 7th cycle, but with slight variations. Each human student saw something different in the puzzle. Bill compared it to engine vibrations. Grace thought it looked like a 3D painting she once made. Owen related it to chemical reactions under pressure. Dr. Zixlera watched them with growing excitement. This is exactly what we hoped for. You're each approaching it from different angles. Meanwhile, on Celestia Prime, the alien team was attacking the same problem with massive quantum computers and theoretical models. They had made some progress, but kept hitting mathematical dead ends. The council has given us 3 months, Dr. Reeves told the students. At the end, both teams will present their solutions. The human team worked in a converted warehouse. The space was filled with physical models, drawings, computer simulations, and strangely, toys and everyday objects they used to test ideas. Jake built a water tank where they could create miniature vortexes. Annie covered walls with number sequences. Bill brought in old engine parts to demonstrate vibration patterns. 2 months into the project, they hit a wall. Their physical models showed promising results, but they couldn't explain why the gravity waves behaved as they did. "We're missing something," Jake said during a team meeting. "Our models show what happens, but not why." That evening, their alien friends shared the council's latest message. The alien team had made significant progress using a new mathematical approach. They were close to a solution. "Maybe we're wasting our time," Bill said. "They have technology we can't even imagine." "No," Krill said firmly. "Your approaches have value. You see things we cannot." That night, Jake couldn't sleep. He went to the warehouse alone and stared at their models. Something about the problem nagged at him. The solution was close, but just out of reach. The next morning, Jake called an emergency meeting. "I think we've been thinking too small," he told the team. "We've been treating the gravity waves as isolated phenomena. But what if they're part of something much bigger?" "Like what?" Grace asked. "Like the galaxy itself," Jake said. "What if these patterns exist because the entire galaxy has a structure we can't see from inside it?" Dr. Zixlera looked stunned. That would change everything we know about galactic formation." "It's worth exploring," Dr. Reeves said. "How do we test it?" Jake looked at his team. "We build the biggest model yet, not just of the gravity waves, but of the surrounding sectors too." As they began working on their expanded model, a message arrived from the council. The alien team had announced they were ready to present their solution. The humans had only 1 week left. "We need to hurry," Jake said, as they worked day and night on their new approach. "This might be our only chance to show the galaxy what human thinking can do." The day of the presentation arrived. Jake and his team stood nervously in a large room at NASA headquarters. A special communication link had been established with Celestia Prime, where the Galactic Council waited. "Remember," Dr. Reeves whispered, "just explain your thinking like you would to a teacher." The massive screen lit up, showing the council chamber. Dozens of alien beings sat in tiered seats, watching intently. High Counselor Dram spoke first. "The Volparian team will present their solution to the Corellian gravity wave paradox, followed by the Earth team." Professor Gulnar, the gelatinous scientist who had doubted human methods, floated forward. "Our solution uses advanced quantum mathematics to model the wave patterns," he said proudly. "After millions of calculations, we discovered that the gravitational constant varies slightly in regions with high neutrino activity." He displayed complex equations and simulations that showed gravity waves bending exactly like the observed patterns. The council members nodded approvingly. "An elegant solution," High Counselor Dram said. "Now, let us see what the humans have developed." Jake stepped forward, suddenly very aware that he was representing his entire planet to an audience of aliens. He took a deep breath. We approached the problem differently, he began. Instead of starting with equations, we built physical models to see the patterns with our own eyes. Jake explained how they had created water tanks, sand tables, and computer simulations. Amy described the number patterns they had found. Bill talked about similar vibration patterns in engines. The council members looked confused. One whispered to another, clearly wondering where the mathematics were. But our breakthrough came when we stopped looking at the waves in isolation. Jake continued. We realized something important. He signaled to his team. They unveiled a large model that took up most of the room. It showed not just the gravity waves, but the surrounding star systems, dust clouds, and energy fields. The paradox exists because we're inside it, Jake explained. The galaxy itself has a structure we can't see from our position inside it, like fish who don't know they're in water. Using simple terms, Jake showed how the entire galaxy rotated in a complex pattern. The gravity waves weren't an isolated phenomenon. They were part of a much larger cosmic dance. The waves look strange because we're seeing a three-dimensional slice of a four-dimensional pattern, he concluded. There was silence from the council. Then Professor Gulnar spoke. This cannot be correct. Where are your equations? Your proof? We have those too, Amy said, stepping forward. She displayed the mathematics they had developed to support their model. Our equations are different because they describe the whole system, not just the waves. Dr. Zixlera was beaming. The human approach shows us something our methods missed. They saw the forest while we examined individual trees. The council erupted in debate. Some dismissed the human solution as too simple. Others were intrigued. High Councilor Dram raised his hands for silence. We will need time to verify both approaches, he said. But it appears that the human method has merit. It provides a fresh perspective on a problem that has confounded us for centuries. He looked directly at Jake. Your species thinks differently than any we have encountered. Perhaps there is wisdom in your Deathworld intuition. 3 months later, the council announced their findings. Both solutions were partially correct, but together they provided a complete understanding of the paradox. The council officially recognized the value of human cognitive approaches. Back in Iowa, Jake received a letter. It was an invitation to attend the Celestia Prime Academy as its first human student. I guess homework really can change the universe, he said with a smile as he packed his bags for the stars. As Jake's ship left Earth's atmosphere, Dr. Zixlera watched from the cockpit. This is just the beginning, she said. Human minds working alongside galactic science. Imagine what we'll discover together.